Object-oriented programming is based on four fundamental principles. That is encapsulation, abstraction, inheritance, and polymorphism. Encapsulation is about having your code in of uh, groups of codes, like chunks of codes taken and getting into box. We call it the capsules, and in Java it's classes. In OP it's classes. You take classes because it is very easy to access all your code connecting to one purpose when you have classes created. Also, to not mess up the code when you're working with it and you want to change something, to not change the whole class's methods, and to not have people access to certain methods. That's why classes exist. In a real life example would be cars. We have planes, cars, books. That's a category, a big category. In it we have different, for example, books, fiction, action, horror, different cars, sports cars, family cars. All of those cars, books, planes are classes, real life example classes. We group them so it's easier to know which is which, to not every time specify, for example, a Ferrari sports car. You don't really need that in everyday life, and you don't really need that in a code too. It's easier to just have classes and have the properties and Maramasın Grasnere inside. The second one is abstraction. Abstraction is the process of simplifying complex reality by modeling classes based on essential attributes. It is essential to have abstract classes sometimes because your code is so complex. For the user, it would be unnecessary to see all of that. That's why you have abstract classes. A real life abstraction example would be, for example, when you're posting an Instagram post, you just choose a photo from your gallery, then click on post, and it's posted yourself. You don't know how the servers work, why your photo is posting. Is it posting only for you or not? Why is it not? Why other people see your post? Do they see it or not? How all of that is written in code. You don't know that. You don't really need to know that. You just click, and it's posted. It's done. That's a real life abstraction example. Next is inheritance. Inheritance is a mechanism that allows you to have one class inside of another, derived or child class. That's an example of cars, sport cars, and family cars. Cars is the parent class, sports cars and family cars are inherited from cars. They are the child classes. We need them to specify, to have specific types of that class, so we don't get lost in all of that. And next is polymorphism. Polymorphism allows objects of different classes to be treated as objects of common base class. It is easier with polymorphism to use methods from another classes and stuff like that. It's very nice to have that. It's very useful. You don't repeat your code again and again and again. Real life example would be, for example, when you're drawing something, when you have a template on your iPad, for example, and you want to draw, and you're making the application very simple for a child, you could make two categories: draw and shape. The child chooses draw, then chooses shape. Inside there's triangle, circle, star, heart, whatever. Triangle, circle, star, heart, whatever is implemented from shape. but in interfaces you just write shape, that there exists shape. When you implement the shape in your classes derived from your interface, there you define what shape is it. That's why we need polymorphism. It's very useful. Sometimes maybe you forget about something to write, and in interfaces you just write that category, and the code makes you write the category's code afterwards in a class, so you don't forget anything, and you have specific description for anything in any class after implementing it.